and is very practical for both beginners and advanced users. The kit is on the form of a plastic toolbox with a handle that contains all the necessary elements and is ready to work immediately after opening. There is also a moisture sensor, an infrared remote controller, and accessories for the servo motor. There is also the microcontroller board that needs to be mounted on the appropriate base. The code is uploaded and the servo moving from 0 to 180 degrees. This is an audio spectrum analyzer with 6 different types of bars that change by pressing this K1 button. Hello! This time I will describe a simple and practical way to enter the world of microcontrollers, specifically Arduino. Arduino is an open source electronics platform that combines simple hardware, microcontroller boards, and software Arduino IDE to let anyone build interactive projects like robots, sensors, or smart devices. It's widely used by beginners, hobbyists, and professionals because it's affordable, easy to learn, and supported by a huge global community. Namely, during the school year, I conduct practical training for students from a local vocational school. In the practical exercises, I used a standard breadboard on which the components were connected with wires. However, it often happened that the device did not function even though it was connected exactly according to the schematic, and the reason for this is poor contacts and parasitic oscillations that occur to the proximity of large metal surfaces on the breadboard. The kit I will present to you is a solution to all these problems and is very practical for both beginners and advanced users. The kit is on the form of a plastic toolbox with a handle that contains all the necessary elements and is ready to work immediately after opening. This saves valuable time, especially when developing a software project. Now let's see what's inside the box. Besides the necessary cables, there is also a moisture sensor, an infrared remote controller, and accessories for the servo motor. There is also the microcontroller board that needs to be mounted on the appropriate base. Now the main part, the lower half of the case is actually a large PCB. Now the main part, the lower half of the case is actually a large PCB on which, in addition to the MCU, all other components are mounted. These are mainly various sensors, then displays, servo motor, LEDs, relay, linear potentiometer, buzzer, and other sensors and components. All these components are connected to the corresponding pin of the Arduino board that are marked near to the sensor. For example, we can see the servo is connected to pin D9 and the relay is connected on D4. So all these sensors and components are connected to a specific pin on the microcontroller via the PCB lines. This means that there is no need of any wiring or soldering. On the Elecrow wiki page you can download a PDF manual of over 170 pages, which describes in great detail with pictures how to install Arduino IDE with proper support for Arduino Nano R4 and install the necessary libraries. Then more than 20 hardware and software projects that use these sensors are also described in detail. You can download the complete codes for these projects on given GitHub page. In this way, creating any of the proposed projects is extremely simple. It is enough to just upload the desired code and the project is ready. In the manual, each line of the code is described in very extensively and step by step. Now I will practically present you the creation of one of the given projects. For example, let it be servo example. First we start Arduino IDE and select the Arduino Nano R4 boards. Now we copy the code from GitHub and paste into the Arduino IDE. This is the servo code on given GitHub page and paste it on Arduino IDE. Previously I copied all the given libraries into the Documents Arduino Libraries folder. Then I connect the USB cable and select appropriate port on Arduino IDE. In my case that is COM6. Now we need to press upload the code. In a short time the uploading is completed and the project is ready. The code is uploaded and the servo moving from 0 to 180 degrees. As I mentioned at the beginning, the kit is adapted for both absolute beginners and more advanced users. For example, we can expand the given code with additional functions, but also create and test completely new code that would use one of the of other given sensors. And that's not all. There are two input-output connectors on the PCB, one for serial communication and other with analog inputs, to which we can also connect one of the many external Elecrow sensors without soldering. Now I will present you a project of mine that uses microphone and LCD display. I adapted the code from a previous project of mine specifically for this training kit. This is an audio spectrum analyzer with 6 different types of bars that change by pressing this K1 button. As you can see, much more complex devices like this can be tested on this hardware. And finally, a short conclusion. Whether you are just starting with Arduino or looking for a fast and reliable prototyping platform, this Elecrow starter kit is an excellent choice. It saves time, eliminates wiring problems, and makes learning electronics both simple and enjoyable.